Rigaku, the leading X-ray analytical instrumentation company, offers QuantEZ advanced EDXRF analytical software with the NEX CG, NEX DE, and NEX QC QuantEZ instruments. QuantEZ software was engineered to be easy to use for routine analyses and easy to understand when setting up new applications and protocols. The top menu ribbon contains icons for all the major instrument functions. This design ensures that you will never get lost and can immediately go to whatever function is required. Rigaku NEX CG was employed for this demonstration video. Click the Empirical Application icon. Select Create New Application in the dialog box and click Next. The powder category is chosen for this cement example. Type in a name for the application, select a folder for data storage, and then click Finish. Note how the left side flow bar guides the application setup process. In Components selection, analytes are selected as either oxides or elements. Note that most components in cement are oxides. Clicking Next brings up the Parameters screen, where measurement conditions and line assignments are automatically set for every component. Tube voltage and current are set automatically. As demonstrated, only the measurement times for a given condition might need to be modified. Measurement atmosphere, either air, vacuum, or helium, may be selected. Note that the elemental line associations are predetermined for the optimal measurement conditions. Clicking Next brings up the Standard Samples table, which operates much like a spreadsheet. Enter each calibration standard and associated assay values. In this example, the NIST set of Portland cement standards is shown. Clicking Next brings us to Standard Samples Measurement. Simply load the standards into the instrument in the order shown by the dialog box. A job table is automatically created. Press Start to begin the automatic data acquisition. Selecting Optimize Parameters from the flow bar allows inspection of acquired spectra from the standards. Clicking Next brings up the Calibration Curve Update screen, where methods may be optimized to correct for peak overlap, absorption, or enhancement effects. Clicking the Correction button brings up the associated dialog box. To enable a correction, click Add and choose the correction type. To observe a calibration curve, select a component and click the Calculate button. Click the Recalculation button to show correlation statistics. Click the Results button to show the calibration parameters and empirical regression statistics. Click OK to exit the calibration dialog window. Clicking Next brings up the Drift Correction screen, where a drift monitor may be easily selected from a list of calibration standards. In this example, NIST SRM 1887A is employed. Select each component to enable, then click OK to exit. Clicking Next brings up the Output Information dialog box, where results reports may be designated. Select the number of significant digits required. One can also select whether to show other information, like intensity, statistical error, detection limit, or quantitation limit. For process control applications, high and low values may be entered for each component to give a pass-fail on the report. Then click OK to exit, followed by Next and Exit to complete. Click the FP application icon. Select Create New Application in the dialog box and click Next. The instrument is equipped with a selection of standard templates, including metals and alloys, oxide powders, fusion beads, polymers, multilayer films, and liquids. In this example, oil is selected, followed by the Next button. Type in a name for the application. Create a folder for data storage and click OK, and OK again. And then click Finish to move down the flow bar to the Component Selection screen. The oil template comes pre-populated with all the common components for oils, which are shown in yellow. Green elements, like sodium, could be measured as well. Purple components are not directly measurable. Simply deselect components that are known not to be present. Notice that the template automatically selects oil as the balance component. For dirty oil, Scattering FP may be enabled by simply selecting the checkbox Estimate Non-Measuring Component, in which case the software will determine the percentage of the sample that is the balance. Clicking Next brings up the Parameters screen, where measurement conditions and line assignments are automatically set for every component. Tube voltage and current are set automatically. Only the measurement times for a given condition might need to be modified. Measurement atmosphere, either air or helium, may be selected. Vacuum is not an allowed condition for oils. Note that the elemental line associations are marked as auto, which means that Rigaku profile fitting will be employed. Clicking Next brings up the Output Information dialog box, where the results report may be designated. Select the number of significant digits required. One can also select whether to show other information. Then click OK to exit, followed by Next and Exit to complete. A matching library is used in conjunction with fundamental parameters to greatly improve analytical results for a specific application. Click the Utility icon and select Sensitivity Library from the drop-down menu. This example will examine modifying an existing soil matching library. Note that the flow bar appears so as to guide every step of the process. Clicking Next brings up the Library Measuring Condition screen. Then click on the Calculating Condition of Intensity tab and enter the elements and measuring conditions for the standards to be used in the library. Clicking Next brings up the Library Samples screen, where clicking the Add Sample button allows pre-measured standards to be imported. Then modify the standard value of each element to reflect the assayed value. Clicking Next brings up the Library Sample Measurement screen. Standards that were not pre-measured may be added here. Click Library Update on the flow bar to examine the results by element. Select an element and click the Calculate button to see the new association that is created between theoretical and measured intensities. Then click OK to exit, followed by Next and Exit to complete. Click the Analysis icon to open the Sample ID settings screen. Double-click the blue bar to open a dialog box. Then select the sample position and enter a sample name. The operator name may optionally be entered. Select the data folder and application. Then select the Results Output folder. Click OK to complete. Additional samples may likewise be added. Click Start to begin data collection. For routine process control measurements, select the Easy Analysis icon. This method is recommended for non-technical users. The screen shows a pictogram of the autosampler and up to 6 applications. An operator selects the sample position and the application to use, followed by entering a sample name and perhaps a username. Additional samples may likewise be added. A job table is automatically generated, along with estimated completion times. Click Start to begin data collection. To view the results of any measurement in spreadsheet format, click the Data Processing icon and select Result Display from the drop-down menu. Find the desired data folder and select a result to view. From this view, data may be exported to a spreadsheet. To view the results of any measurement in report format, click the Data Processing icon and select Quant Calculation from the drop-down menu. Find the desired data folder and select a result to view. By clicking on the Components button, an FP application may be modified and the result recalculated. In this example of FP analysis of soil samples, scattering FP was disabled and oxygen was added as a balance component. Click OK to exit, followed by the Calculate button to view the revised results. To view the spectra from any sample, click the Data Processing icon and select Spectrum Display from the drop-down menu. These data views are useful for qualitative analysis and forensics. Find the desired data folder and select a result to view. Click the Open button. Zoom controls are used to view trace element peaks. Click Marker from the top menu and select Periodic Table from the drop-down menu to bring up the KLM Marker dialog box. Hovering over an element temporarily displays that element's line markers. Clicking on an element toggles the marker on or off. Rigaku, leading with innovation. Visit us today at rigakuedxrf.com.